size, not pump size. Always remember, if you double the diameter of the pipe, you quadruple the water flow. A 2-inch pipe does not run twice as much water as a 1-inch pipe. It runs 4 times as much water. And just so you get your high flow rate, and this is volume per foot of water cubic inches, and you can just see as you go up from the 3/4-inch lines, 1-inch lines that a lot of us like to put in, to 1.5 or even 2-inch lines, the difference is huge. Now, something about putting in pipelines, a lot of time, particularly if you're backhoeing, put water lines in a rocky environment like a lot of the Ozarks here, it costs way more to dig the trench and cover it than the cost of the pipe. The big part of your pipeline cost is the machine cost of putting it in, not the difference between a 1-inch pipe and an 1.5-inch pipe. So I always recommend figure what you need and then go a pipe size larger. If you do all the calculations and it says 1.25 inch pipe should do the job for you, go ahead and put in 1.5 inch. If you want, go ahead and put in 2-inch. You will have the water if you do that. And you don't want to have to replace water lines that you put in. So be generous in the size of pipe that you put in. And then this is for buried line. Obviously, if you're just running over the surface water lines and you don't have the trenching cost, and it's not going to be a big deal to replace it if it isn't the right size, you can go, with what your calculation says your pipe water.
Hey Jim?
Yeah.
Is it a linear, can you go, if you're going to hit a water tank with 25 pairs or you hit it with 100 nannies, do we look at it as body weight,
okay,
all being equal, or do I need to upscale that water if we're going to go to smaller and increase the intensity of animal contact?
Good question. Do you figure water demand across species just on body weight? No. Sheep are much more efficient in water use than cattle are. Goats are even more efficient than sheep. So if you put it on a body weight equivalency basis, and usually I use 6 sheep per cow. So if we had 100 cows, 600 sheep would be equivalent body weight. But those 600 sheep are probably only going to use 70% of the water that the comparable cow herd would do, and goats would use a little bit less. So, when you're planning for sheep and goats, the demand it's a different factor, and you can get tables. I know from NRCS, probably from Extension, that for different species of livestock have what the typical water demand per hundredweight of body is, and you can plan on that. When they're lactating, even when they're lactating, like we figured, cows need 3 gallons of milk per gallon, 3 gallons of water per gallon of milk produced. On sheep, it's about a 2-to-1 factor. At maintenance, the difference is even more dramatically lower. A dry ewe has very, very, very low water requirement. Okay, if you don't have recharge rate, that's when we go to larger tanks. And larger is a matter of perspective. A lot of the ranches that I work with out in the West now, when we talk about a large tank, we're talking 30, 40, 60, even 80-foot diameter tanks. Because if you've got 1,800 cows on a 100,000-acre pasture, and they're traveling up to 3 miles to water, all those cows want to be able to get around the tank and get a drink. And so these grain bin, making stock tanks from grain bin rings is common in the West. And 30, 40 foot are kind of the most common sizes, but I've seen them up to 80 feet diameter. And they want to have typically a minimum of 1 day and preferably 2 days worth of the total water requirement sitting in that tank. And a lot of that is because they have very low recharge capacity. When we first started doing splitting up pastures up in the research, yes sir, ma'am.
Getting back to your statement there, if you have low recharge capacity, is that a pump issue as well? In other words, do you need a smaller capacity pump so that you don't?
Okay, the question is can a low recharge issue be related just to the pump?
Well, no, actually what I was asking was if your pump is pumping, if your recharge is slow, can your pump actually pump you dry sooner than you would want it to? In other words, do you need...
Oh, okay. You're asking, can you pump the well dry because of the increased demand on the pump?
Because of
Yeah. Yeah, you can, as the demand goes, just a minute. If you have a pressure tank system with a float control in the tank, the pump is going to run much longer if there's a constant demand in the tank, and yeah, you can run the well dry. Is that what you're asking?
Well, what I was curious about, and I don't have that much knowledge about well systems, but or pump systems, but if my sump, so to speak, is not going to recharge at a certain rate, and I put too much pump in there, that will fill up my tank quick, but discharge my sump too quickly. Is that possibly?
Yeah, the pump on the well or the spring sump, whatever you have, that pump needs to be sized appropriately to the resupply capacity down in the well itself.
Okay.
If you have an oversized pump, you're going to drain that well much more quickly. I'd say in general, a fully drained well does not recharge as effectively as a well that is maintaining, a static water level, and that has to do with braking. It's not really capillary flow, but the lateral flow of water in the strata. If you pump the well out too quickly and you break the continuity of water flow in the aquifer and the sand that the well is drawing water from, you can talk about killing a well. I don't know if that's a term that's used here, but you can kill a well by breaking that flow, and the well will never recharge. So it is a factor. It is important to make sure that the pump capacity is appropriate to the supply capacity of the well or the spring.
Thank you.
Yeah. It's tough to solve. There's not very many problems that you can solve just by putting a bigger pump on it. Usually you create more. Okay, when we first started splitting up pastures up at the research station at Linnaeus, and this isn't Linnaeus, but I have this picture here. I never took a picture up there, I guess. Actually, I did, but they're all 35 millimeter slides, not digital. But we would take a tank and run an electric fence over the top of it. Then when we decided that we wanted to split the pasture again, so we would have more subdivision, so we could go to a higher stock density, all of those things, we might just run another wire. And so you have what used to be a tank that was large enough capacity to serve the herd that's in here. We reduced the accessibility by half and then by quarter, and now we don't have a big enough tank there because we split over the top like that. The other thing that happens, and picture this as being a steel tank, not a Rubbermaid tank. Think of yourself as being an animal with your face down in the water in a steel tank getting a drink, and the boss cow comes and shoulders you aside and knocks you into that electric fence. You can train cattle to not drink water through that kind of experience. So to me, this is an absolute no-no. Never run a hot wire over the top of a tank unless it's a really huge tank. So we started using the water block design, where we have a tank located at the juncture of 2, 3, 4, 5 paddocks, whatever, and the different pastures come into this area to drink, so the animals have access around the entire tank and no electric fences close to them when they're getting a drink. Basically, this is the starting point that we do. The water block, we have permanent fences coming in from I don't know where that fence went, but they're, 4 paddocks come to water at one point. About 30 foot is the closest we ever put these, so 30 foot by 30 foot water block is about as small as we make. We say 30 to 40 feet for up to 300 to 400 pairs, and again, because so many of the outfits I work with now have larger herds than this, basically we add 10 foot to the side for each additional 100 head of the herd. So if we were running 800 cows in a bunch, we'd be 80 by 80 on the water block, and of course the tank would have increased in diameter in there also because of the greater demand.
Well, can you downsize that if you're saying running stockers and running about maybe 100 stockers?
I wouldn't make it any smaller than that. This is the reason why. What we want is we want 2 animals to be able to pass behind the drinking animals without anybody pushing or shoving. You think about how long, even a stocker, let's say we have a 6-foot tank there, and we have a stocker who's getting a drink of water. He's probably going to be, about 6 foot out to his butt here. And then we want 2 other animals to be able to pass behind them without, having to run into each other, not having to push against the one getting a drink. And so it just kind of works out. On a 30-foot water block, you have 15-foot clearance from the center of the tank to the electric fence. You take 3 foot for the tank, 6 foot for the animal, that's 9. You only have 6 foot left for those 2 animals to pass behind each other there. So 30 foot is about as small as we want to go.
Because I was thinking about making a lane for them, making about a 20-foot lane, and having the water at the end.
Okay. Again, at the research stage, when we first started doing a lot of grazing sales up there, we did a lot of lane access to water, and have water points located in the lane I can't remember if we had 24 or 30-foot lanes. I think we probably had 30-foot lanes. And in that situation, the 30-foot was about as narrow as we wanted to go with them, just from an animal behavior standpoint and how they interacted when they were getting a drink. A lot of what we're doing is where everything starts coming together is we also want to keep the stress load on our livestock very low, because if you keep the stress load very low, your animals aren't going to get as sick, aren't going to get sick, the performance is going to be better, and there's a lot of meat quality, at the end of their life is going to be better, everything is better. The lower you can keep stress, the better everything's going to be. So we want them to be very comfortable in the situation of where they're going and getting their drink. And they're, got an increase of 10 feet per head for 100 head over 400. And stockers, I get this question actually quite a bit about, well, you're talking about cows. Can we do something different for stockers?
Stockers.
And in my experience, I really don't like, when we have tried to put stockers into a little tighter situation, I don't like it. Because it seems like they don't like it. So we kind of stick with this guideline. Okay, when we put in water tanks, we always put them on a raised pad. Even, this is in northeast Nevada, out in the desert, and you still got a mud hole around the water tank. It's always possible for a valve to break, for lines to leak, or whatever, and we don't want to create mud holes like this, and the opportunity for the cattle to work all the ground away from the water tank